Okay, we are continuing our pursuit of the solution to linear equations of one variable. And now we're going to trick it up and combine the two things we've learned so far. I don't have 1x, I've got 3x, and I've got this plus or minus another number in my way. So I really need to tackle both of the things we've already talked about. Okay, and ultimately it doesn't matter which one I do first, but one way is usually a lot more simple than the other way. Okay, and in my regular algebra classes I do it the harder way and I stumble and I make a mistake and I see who can catch it and all that, but here I'm just going to kind of cut to the chase. Okay, so we want to get rid of this 1 first. The last thing we're going to do is divide by the number in front of x. Okay, so let's get rid of the 1 by subtracting it from both sides. 3x equals 7 minus 1 is 6. Divide by that 6. Divide by that 3, pardon me. Divide by the 3 in front of x. Divide by 3. And we get x equals 2. Okay, I didn't mention it before, but the beauty of any equation is that you can check yourself. Okay, and we won't take the time to do it other than this one time. Take your problem and take your calculated answer here of 2 and put it in here in place of x. And you better get a true statement on the board. If you don't get a true statement on the board, there's something fishy here. Okay, and you see I get 7 equals 7. Doesn't matter what the statement is. 0 equals 0, a million equals a million, 7 equals 7. As long as it's true, you know you did a good job. Okay, so that's the check. The answer is 2. The answer is not 7. Alright, now you're going to see there's a couple of cases of equations that we either can't solve at all, or we're going to find that there's an infinite number of solutions to those equations. So we gotta understand the difference between that and just checking the problem. Here the answer is 2, and then when we checked it, we got a true statement, which is good in this case. Okay. All right. Let's do another one. Negative 2y minus 28 equals 4. Okay, again, the last thing I'm going to do is divide by that number in front of y, so let me get rid of the 28 by adding 28 to both sides. Negative 2y equals 32. Divide by that number next to y. Y equals negative 16. See, here's where just knowing your negatives is so important. You shouldn't have to think that that's a negative 16 when you're doing that. Okay, you should, hopefully all that stuff is pretty well absorbed already for you, and you can just dive into this stuff. Okay? Okay. Let's look at this next one now. Now, here's an interesting situation. 3x minus 14 equals negative 2x plus 6. I have x's on both sides, and I have constants on both sides. Okay? It doesn't matter which side I put the x's on and which one I put the constants on. So I'm going to work this one both ways just to demonstrate it. Typically speaking, if everything else being equal, I'll just put the x's on the left, just out of habit. But it really doesn't matter. Okay, so let's put the x's on the left. So I want to make the x disappear over here, so I do the opposite of what I see there. I see a minus 2x, so I'm going to add 2x to make it go to 0. Add 2x over here, so that now becomes a 5x. Minus 14 equals 6. Make the 14 disappear over here. 5x equals 20. Divide by 5, divide by 5. X equals 4. Okay? All good? Let's do the same thing, except let's put the x's on the right this time. So let's make the 3x disappear. Minus 14 equals negative 5x plus 6. Subtract the 6 from both sides. Negative 20 equals negative 5x. Divide by negative 5, divide by negative 5. 4 equals x. 4 equals x and x equals 4 are of course the same. Makes no difference. Now you may have noticed a lot more negative signs this way than we had this way. dumb luck. Okay, we could have had all the negatives over here and no negatives over here. So don't let this one example discourage you one way or the other. Okay, it's luck of the draw on which way may give you more hassles with the negatives. They both work out the same, and you never know which way it's going to go until you think it through a little bit. Okay, so don't worry about this particular example having more negatives this way than this way. That's not always the case. Okay, so that's our basic thing. Let's just trick it up from here. And we'll do more and more simplification before we actually solve. Okay, but then we'll just keep solving. That's good. All right, what about this one? How about 2x minus 8x plus 40 equals 13 minus 3x minus 3. Now before we actually start solving, we're going to simplify. And simplifying is combining like terms. Don't confuse simplifying with solving. We're not going to cross that equal sign just yet. I'm just going to look at the left and say, oh, I know how to put a 2x and a negative 8x together. That gives me a negative 6x. And I know how to put a 13 and a minus 3 together. That gives me a 10. Okay? Combining like terms. Don't confuse that with what we're about to do now. Now we're going to really solve. X's on one side, constants on the other. I'll just throw the X's on the left, so I'm going to make that disappear. Okay, notice I did the opposite. Up here I wasn't doing the opposite. I was combining like terms. Here I'm like doing the opposite. It's minus 3x. I'm going to add it because I want it to go to 0. That goes to 0, right? Minus 3x plus 3x. 0. Gone. Goodbye. Now it's over here as a minus 3x plus 40 equals 10. I want that 40 to go to 0. 40 minus 40 is 0. Bam-o. Off it goes to 0. Gone. Minus 40 on this side. Negative 3x equals whatever 10 minus 40 is. That'll be a negative 30. Divide by negative 3 on both sides. And I'm going to get x equals a positive 10. Negative 30 divided by negative 3. Positive 10. Okay? Sweet. Let's trick it up from there. 5x equals, you know what to do, 8 parentheses, x plus 3. So first I need to distribute over there on the right. 5x equals 8x plus 24. Right, distribute my 8. Okay, now I don't have a constant on the left, so it would be silly for me to try to move the 5x over to the right, because then there'd be nothing left on the left. So in this case, I really don't have a choice. I want the x's on the left, and that's what I normally do anyway. So subtract 8x from both sides. Negative 3x equals 24. Divide by negative 3. X equals negative 8. Linear equations of one variable are really pretty straightforward to solve. Okay, they really are. Okay, let me just trick it up one more time here. Let's see, it's sneaking in over here. 2 parentheses, x minus 3, close parentheses, minus 17 equals 13 minus 3, parentheses, x plus 2. All right, now we're cooking. Okay, distribute. 2x minus 6. Bring down the minus 17 equals 13. I'm distributing a negative 3 across, so it's minus 3x minus 6. Don't forget to distribute the negative along with the 3. Okay, next step, I'm still just combining like terms. I'm not crossing over the equals yet. I have not breached the equals, right? I got 2 separate sides. There's still 2 separate sides. I've got to put this together. A negative 6 and a negative 17, so that's going to be a negative 23. And I've got to put this together. A positive 13 and a negative 6. Well, that's going to give me a 7, right? 7 minus 3x. All right, all good. Let's put the x's on one side, the constants on the other. I'll add 3x to both sides. That'll give me a 5x minus 23 equals 7. Add 23 to both sides. 5x equals 30, okay? And then that last step now, I'm going to divide by that 5. Yeah, well, I can sneak in divide by 5 and divide by 5 right there. X equals 30 divided by 5. X equals 6. Okay? Okay, you might get an equation that has a lot of goofy looking fractions in it. There's a way to clear those fractions out so we don't really have to deal with fractions so much. What if I had this one? 3x over 2 equals x over 5 minus 39 over 5. Okay, choice number 1 is just deal with the fractions. What does that mean? Well, if I'm going to add, I gotta subtract x over 5 from both sides, right? And then I got to deal with the subtracting of those fractions with different denominators and all that. The other choice is to what we call clear the fractions out. Okay, and to clear the fractions out, you got to look at all denominators and find the common denominator of all denominators. Okay, so I've got a 2 and a 5, so my common denominator is a 10, right? I'm going to multiply through the entire equation, numerator only, so I'll call it 10 over 1 so I don't forget, by that common denominator. Okay, let's try that. What does that do? That gives me a 30x over 2 equals a 10x over 5 minus a 390 over 5. Okay, now that looks terrible. That doesn't look better at all, does it? Well, it is better. And why is it better? Because look, 30 divided by 2, that's just a nice pretty 15. So it's 15x equals 10 divided by 5, so that's a nice pretty 2x. And 390 divided by 5 is a nice pretty 78. So all of our fractions have magically disappeared. We cleared them out. Okay? Put my x's on the left, subtract 2x from both sides. 13x equals negative 78 in this case. I'm going to divide by 13 on both sides. X equals negative 6. Okay, so an equation that has fractions like that, we can clear it out as long as we multiply through the numerator only by what would be the common denominator, and then everything divides away nicely. Okay, so that's a kind of a trick with a fractional equation. All right, there's two specialty cases. You've noticed with every one of these problems, we've had exactly one solution, right? Not 2, not 3, not 4, 1. Okay, well, here's a couple extreme examples. What if I asked you to solve this equation here? What if I asked you to solve, x equals x plus 4? Look at that thing. We're looking for, it's a balance, right? We're looking for a number that we can put in there for x and have this thing be balanced, like a balance scale. And if you think about it, both sides have whatever this mystery x is going to be, but this side's always got 4 more than the other side. Always. No matter what. So there's no value of x I could ever stick in there and have this thing work out. Okay, you see that? So let's say we don't just kind of spot it, obviously, and we're gonna do our method of solving here, right? I'm going to put the x's on the left. So I'm going to subtract x from both sides. Well, x minus x is 0, and I'm left with that on the board, on the paper. 0 equals 4. Last time I checked, that's a false statement, right? And if this happens, if the x's disappear and I'm left with a false statement, that means there is no solution. No solution to this problem whatsoever. It doesn't work. Not one number will work. Nothing will work. Okay? Another way to say no solution is empty set, which is a 0 with a slash through it. Now, I know some people make the regular zeros that way. I'm not a stickler about it, but if you're ever in some math class, you might get a stuffy professor that frowns upon zeros being shown that way, because that's not a 0. That's an empty set, and an empty set means nothing. 0 sounds like it's nothing, but 0 is a perfectly good number, just like some other number on the number line, right? Empty set means there's no number. There's no number whatsoever. If I put 0 in here, that's not going to work. 0 equals 0 plus 4, supposedly? No, that's not going to work. Nothing is going to work. No number, an empty set. Okay? That's one extreme. Here's another extreme. Okay? Another extreme is something like this problem here. Negative 3x plus 5 plus 5x equals 4x minus 2x plus 5. Okay, let's look at this one. Well, I can simplify each side individually, so let me do that. A negative 3x and a positive 5x, that gives me 2x plus 5 on the left. And on the right, when I take my 4x minus 2x, I'm going to have 2x plus 5 on the right also. Look at that. So if you stop here and think a minute, this is a balance, right? The balance scales. No matter what value I put in there for x, they're identical, right? No matter what I put in there. I could put x equals 0 in there and they're balanced. I could put x equals 10 gazillion in there and they're balanced, right? It doesn't matter what I put in there. They're always going to be the same. So here we say there's an infinite number of solutions because no matter what I put in there, it works every time. Up here, nothing worked. Okay, your typical problem, only one answer is going to work. Here, nothing worked. Here, everything will work. Well, let's just finish it off. Let's put all my x's on one side like I normally do. Once again, the x's all disappear, but you see what I'm left with on the paper now. I'm left with a true statement. Okay, here's what I was mentioning before when we were checking problems. You're looking for a true statement. Well, this isn't a check. This is the problem itself. If the x's all disappear and I get a true statement staring at me in the face, then I say there's infinite solutions. Okay, all what we call real numbers will work. Okay, all real numbers will work. Infinite number of solutions. Okay, good deal. All right, we're gonna talk about formulas in the next video, and we're gonna finally tackle that percent problem that we alluded to way back when we were just first discussing percents. We're gonna work some actual percent problems where we have to write down an equation and then solve the equation. Okay, so that'll be next.